Hey, how you guys doing? My name is Billy Hoffman. I'm the lead researcher at Spy Dynamics. We're a web application security company, and actually we have a booth out there. And because I'm not a sales guy, I won't tell you anymore. But if you're interested in web AppSec, because you're sitting in here, so hopefully you are, you should go talk with them and see if we can't help you out. Okay, so what am I going to be talking about today? Well, as the title slide said, we're going to be talking about web application worms and viruses, basically JavaScript malware. What are all the nasty things I can do with JavaScript, and even talk about other types of worms that exploit web applications. Perl.santy, there's been some other self-propagating attacks. And they're really neat because they will work regardless of whether you're running, PHPBB on some Apache box on Linux or PHPBB as, some plugin with a PHP extension for IIS on a Windows 2003 box. So the whole point of this is the migration of self-propagating code from being application, processor, operating system specific to actually transcending all of that and being truly cross-platform. So why should you care about all this? We're going to talk about that. We're going to see why exactly these attacks against web apps happen. We're going to specifically discuss the web application worms and viruses. We're going to do a detailed analysis of Perl.santy, the SAMI worm, and the Yahoo Yamana worm that hit in June of this year. We're going to say, all right, so SAMI, Yamana, these things are neat and cool. Hypothetically, what's the worst thing somebody could do with these things? Because it's always good to sit around and think about how to be evil while you're thinking about how to be good. And finally, I'm going to go through some quick guidelines about how you can actually write a secured web app. Because, there are a lot of people who will get up on stage, not at this conference, Black Hat's really good about filtering people out, but I'll go to conferences where people get up here, scare the crap out of you, and then say, buy my, 10 grand product and you'll be safe. And so, Spy does sell a product, but everything I'm going to tell you today, you can fix without spending a dime, and I'll go ahead and talk about guidelines for just writing secure code. Now, if you'd like an automated way of doing this, you can go talk to us, but we're just going to go through how you can protect yourself. So, also, I tend to talk kind of quick, so if you have trouble hearing me, or you didn't understand something, or you've got a question, just raise your hand, and I will answer it. I'd rather do that now than at the end. So, you guys ready? That? You guys have all the ice cream in you. You're just like, I've got Hershey's, I'm good, keep going, man. So, all right, why should you care about all this stuff? Well, quite frankly, web applications are not going away. They just offer way too many advantages for businesses. Browser is a ubiquitous platform, available on all operating systems and patch levels. So if I'm running, say, an insurance, entry, data farm, and I've got a bunch of people just doing data entry, I could create an application, a Windows application, and install it on a bunch of machines. And as soon as a new version comes out, my IT guys will spend a couple of days going out to all these hundreds, if not thousands of machines, installing a new version. Or all of these guys could have the ubiquitous web browser platform pointed at a central site, and that's where the software is. And as soon as a new version comes out, I tweak it. But y'all wouldn't know this. Google is constantly making enhancements to Gmail and Google Maps. You don't know because you don't have to do anything. They just push it to production, and it's there. So this ease of being able to maintain just a single server, this ease of being able to only have a couple things you have to upgrade. As soon as there is a bug, you can immediately fix it. It's easy on the budget. It's kind of funny how everything old is new again. This is slave master communications. This is time sharing. We've got a central machine with the application is. We got a bunch of done terminals using a browser here in this case to connect to it and actually interact with the application. So it's appealing to budgets. Large applications are already doing this. I mean, Salesforce.com basically stakes their business on having a web application to manage customer relationships. Google has a bunch of apps. Microsoft has their upcoming Google Live and Office Live. I really can't think of a worse idea than having a full Office suite and components of your operating system operating over the internet. But if that's what they want to try, we'll see if they actually push it out. So why should you care about this? Not only are they not going away, they're here right now, and web-based attacks are getting worse. Gartner says 70% of all attacks come in through the application layer, not the network layer. This just makes sense, right? If I got to bypass some IDSs, I got to pop a firewall, I've got to actually drive to your office and try to find an access point that wasn't secured or crack web or whatever to get in, and then privilege escalate and do all this stuff to get to your database. Or because you're running an e-commerce site, your website by very definition has to talk to your database. I can just pop your web app and then get to your database. I'm going to take the path of least resistance. I'm going to attack you through the application layer. It's easy. Developers don't secure it. We've kind of already solved a lot of the problems at layers 3 and 4. We haven't really solved a lot of the problems at layer 7. Attackers know this, and as we see, they're just increasing their attacks here. Web-based attacks certainly are not going to go away. There's such a low barrier of entry. Everything I'm going to show you here today, you can do with the web browser. Right now, you guys can go home, assuming you have a site's permission, and do everything I'm going to show you. You don't need sophisticated tools. You don't need to know assembler. You don't need to be, like a ninja at x86. You don't need to understand firewalls. You don't have to, predict sequence numbers to hijack TCP sessions. This is easy stuff. This is so script kiddie friendly. I'm surprised there aren't more tools that are allowing script kiddies to crack web apps. These vulnerabilities are everywhere. I mean, go see Johnny Long's talk on Google hacking. And the funny thing is about Johnny Long's Google hacking, right? That's not even low-hanging fruit, where you have to go and you got to find it and then you exploit it. That's fruit that's already on the ground. I'm going to use Google and I just found a credit card database, or I'm going to use Google and oh my gosh, here's the default login to your Netscape enterprise system or whatever. So not only are these things extremely easy to find, whenever a site reuses common components. We've all seen PHPBB, PHPB gallery, PHP, whatever. Thank God for SourceForge and PHP whatever, because that's what's having this rich site, or this rich source of applications that are full of vulnerabilities. And whenever you reuse a common component, I like, photography. So I've got a site about photography, and, I want to put a forum on it. Well, I don't really want to write forum software, so I just go to SourceForge and grab some. So I'm kind of putting trust that the people who wrote that software know what they're doing. Well, the scary thing is that if you have something like PHPBB or some of these gallery software, if they're used on hundreds, if not thousands of sites, and I find a vulnerability in one, I haven't just attacked this one host, I've attacked everybody who's used that component. So the risk, the return on investment of trying to attack a website works, because not only sometimes are you able to attack a website, you actually attacked a common component, and so you really found out how to attack thousands of websites all at the same time. Also, even if you happen to stumble upon a site, you want to hack a bank in New Zealand or something, and they happen to be secure, you've got Google, you've got the whole internet. There's someone out there who's not as smart as the Bank of New Zealand, and you just go ahead and find them. So, and Google facilitates this. So the targets are everywhere. It's incredibly easy to do this, and so we're seeing a rise in the attacks. So web-based attacks are high profile. You can get the same type of information out of a attack against a web app as you can of going in through layers 3 or 4. There's been some rumor. I had actually heard the way Paris Hilton had her address book stolen off T-Mobile was that there was a web interface on T-Mobile that lets you view your address books, and they SQL injected it. I've had some people tell me it was like a social engineering, so I really honestly don't know. But I have certainly seen a lot of high-profile attacks where people will SQL inject it and steal thousands of credit cards. Whenever you see these things in the news reports about some Russian group taking hundreds of thousands of credit cards, it's because they're grabbing the entire database. And if they're grabbing the entire database, they're either going in through layers 3 or 4, or they're going in through the web app and they're doing SQL injection. Like we said, web-based attacks can yield the same results as traditional attacks can. I can get usernames and passwords. I can get credit cards, order numbers, confidential or classified information. I could, steal everybody's shopping cart on a major bookshop and start outing people who are very staunch Republicans but are buying lots of gay literature. You can blackmail people. I'm not saying you could do that or that happens, but I'm just saying it's information, and information always has a price, and someone's always willing to pay for information either to be suppressed or somehow not released. So needless to say, automating attacks against web apps, because obviously there are a lot of them. But if I can create a tool that will actually automatically attack sites and check every single input and totally destroy it, that's bad. But if I manage to create an attack, or if I create a script that will actually self-replicate and actually exponentially attack you faster and corrupt more and more of your web app, that's really, really bad. And it only makes the dangers from all these things worse. So why do these attacks happen? Kind of talked a little bit about this morning in my Ajax talk. Web apps are complex. I mean, they really are. You've got, multiple technologies, multiple disciplines, and you get a whole lot of this, that's not my responsibility. Because if you look at this from an IT perspective or an infrastructure point of view, you've got some DBA, some database admin, who's in charge of setting up maybe some stored procedures. He's got to put up some backup jobs. but he's not really dealing with, he doesn't have the job of writing the server logic. So he's going to say, well, you know, no one will ever ask me, or you know, the server will never ask me to try to fetch a primary key that doesn't exist, or try to insert over these records, or null these things out. You know, it's a foreign key, but I didn't mark it as a foreign key. There's a certain trust and assumption between the database and the server. But the server guy, the database guy will be like, oh, the server will make sure that this is a good request. And the server guy might be thinking, okay, well, I've got my web app designers, and they're going to implement some type of client-side JavaScript layer, which actually validates the input, so I don't have to worry about validating input. Somebody else did that. And you guys can see, you drop the ball pretty quick, because you got IT administrators who are setting up permissions between the box. You got DBAs who are setting up the databases and writing the store procedures. You got application programmers who are writing the glue to hold all this stuff together. And then you've got people who actually design your website, which very well could be an external firm who has no concept of what your security procedures are. And so all of these people kind of assume somebody else does it, and what that means is that nobody did it. And you also get this thing that we call at SPY the web application security gap. And you also get kind of how the application was designed versus how the application actually ended up getting implemented. Just real quick, I want to clear up a couple myths. Layer 7 is dominated by very simple protocols. Don't confuse simple protocol with limited. HTTP, I mean, it's got some weird caching stuff, but incredibly simple. You can browse the internet using Telnet and actually get some pretty interesting results. But don't think that these simple protocols are, you can't do lots of nasty things. And because of this, people tend to have a lot of misconceptions about web application security. The biggest one being that SSL is something that is encrypted and it'll protect you from anything because you're encrypted, right? And the other thing was the impact of common vulnerabilities like cross-site scripting. Now, actually, I have to thank Jeff and Black Hat for having me present this here. I originally presented this at Black Hat Federal in January. And this is actually a very timely talk because when I presented this, things like the Yahoo Yammer worm hadn't hit. A lot of the stuff I was talking about still had been proof of concept. We had started seeing the MySpace worm, Perl.Santy, but in the last 6-8 months, we have seen lots of very nasty stuff. And hopefully this last point, certainly if you've been in any of the talks today, this perception that cross-site scripting means I can steal your cookie and pop an alert box, who cares about that, has been eliminated. Because you can do a lot of things with cross-site scripting. So first of all, these people who say SSL only, that's silly, stupid logic. SSL simply creates an encrypted tunnel between two parties. It provides confidentiality. Nobody else can listen to what you're saying. Integrity. Nobody can change, as I'm talking to Kevin, nobody can inject stuff and change what we're saying. And also authentication. I know I'm talking to Kevin. Kevin knows he's talking to me. SSL is not the application layer. SSL is either layers 4 or 5. Everything I'm talking about is the application layer. It works equally well over SSL or HTTP. So everything, SSL does not protect you from most, if not all, web application attacks. In fact, SSL can hurt you. And the reason SSL can hurt you is, think about what I said. SSL creates an encrypted tunnel. If there's an encrypted tunnel between myself and the web server, how is your IDS supposed to listen to our conversation? Unless you're giving your SSL keys to your IDS system, or your IDS system is the same place where your web server is, which simply does not happen in enterprise environments because of the performance hit, your IDS can't see a single thing I'm doing. So you might have the latest and greatest SQL injection checks in your IDS and your IPS, but it doesn't matter because I'm going over SSL and your IDS isn't even seeing the attacks that I'm doing. So this concept that SSL protects you is wrong, and in fact, SSL can actually hurt you. So you need to not rely on SSL to protect you and actually try to implement proper web security. So real quick, a word about cross-site scripting vulnerabilities. Maybe 5 years ago, cross-site scripting was all about popping cookies and alert boxes. It's much worse now. I actually was thinking about putting together a presentation about the JavaScript language and what about it makes it very interesting. It's a very simple scripting language, but it has very complicated string manipulation functions in terms of regexes. It can do remoting. You can actually make service calls and almost have like a master-slave relationship. It can make HTTP requests using AJAX or some of the other DOM things like image tags and iframes. Its speed was kind of a problem today, but I mean, y'all have 2 gigahertz machines, right? Because you got to run Word, so I mean, speed isn't really a problem. No, I'm serious. In '97, your average person had a P150, and if they were just browsing the internet, you know, that's probably what my mom had. the time. And, you know, do you remember how slow P150s were when you had 32 megs of RAM and you were running Windows 95? That was really slow. I mean, it seemed quick, but when you load up the big bloated web browser, because they kept throwing stupid things like layers and all this other crap from the browser wars in there, I mean, those things were slow. But the browsers are very trimmed down. They're very quick. IE7's fast. Mozilla, Firefox, those things are fast. And the fact that, you know, you download script, the script executes almost immediately. Even though it's interpreted, it's executed really quick. The other thing that people say is cross-site scripting is very difficult to detect and create a payload for. Normally, you had to handcraft a cross-site scripting payload. I'd find a site that was vulnerable, I'd figure out what I'd want to do, and then I'd figure out what payload I wanted to use. Well, actually, back in September, I spoke out at TourCon, which is a great conference in San Diego, about cross-site scripting and using it to try to facilitate various types of, you know, phishing and identity theft. And I wrote a tool that would find cross-site scripting, and it was like a Metasploit for web apps. It would find a vulnerability and just had a big library of payloads to drop in. And so you separated the payload from the code you need to actually exploit the web browser. And it looks something like this. And I always know I'm onto a good idea when I talk to my friend Tom Cross, and he just looks at me and goes, Billy, this technology has no legitimate use. Because it means I've found something that's pretty cool, even though it probably has no legitimate use other than, you know, owning people. But I found this, I wrote a tool called Cross-Site Crafter and No You Cannot Have the Source, which would find all these vulnerabilities, and it would just say, insert your cross-site scripting payload here. And I can't do a demo for you, but I had payloads for key logging, for remoting using cross-site script proxy, some other stuff. And it was just drop the payload in, owned. Now, you attach this to something like using Johnny Long's Google hacking as a front end to find sites. You do this to actually interrogate the site, find the exact vuln. It would dynamically build a string, and then we would, in fact, we actually patent this. So if y'all want to try it, we'll sue you. The dynamic building of attack string, and then just drop a payload in. And you could start owning the entire internet very, very quickly. All right. I'm going pretty quick. Is this making sense? Everyone's still in their ice cream? Good? All right, sweet. All right, so let's try to talk about some of these web application worms and viruses I keep talking about. So traditional attacks are still plentiful. Don't get me wrong. You can SQL inject and cross-site script and, you know, path truncate and all sorts of stuff to your heart content. I'm certainly not saying that those attacks aren't meaningful anymore. They are. I'm just saying now we have programs that self-replicate. They automatically find and then exploit web application vulnerabilities and then use that host to find more web application vulnerabilities, exploit them, and it grows exponentially. I really kind of break this up into two things. In fact, when I wrote this in January, I was really solid on this terminology. And I've kind of waxed and waned over it, but when I explain it to people, it makes sense. You've got web worms, which are really malware that can propagate from one host to another. I infect google.com. From there, I'm able to infect yahoo.com. I'm actually infecting separate sites. In HD's talk, he talked about sites as being little islands. And like the MySpace attack and things like that, it infects everybody on the island, but it doesn't hop. These are things that are almost like plague victims in canoes. They destroy one island, go to the next, destroy that island, go to the next, destroy that island. We're going to hop from host to host. So these are normally language independent. Well, they can be, I meant to say host, well, you can write these things pretty much in any language. People write them in Perl, people write them in Ruby. You can actually write them in cross-site scripting, but I actually cut that so I could talk a little more about the Yammer worm. They're somewhat OS independent. A lot of times, these worms are exploiting, say, a remote code execution in you know, PHP bulletin. And the payload that I want to run is, you know, to, you know, delete some files and you know, deface the site. Well, you know, I'm going to have some RM commands and things like that if it's Unix, but I'm going to have some delete commands if it's Windows. So the payload somewhat has to be OS independent, but, you know, you can kind of fake it. These worms run on the web server. I send an attack, I exploit some vulnerability on a web server in a web app, and then I basically get code execution on that server. And then from that server, I use that as a launching pad to detect, find other hosts, and then go to them. But the key is the code execution occurs on the server for these. It spreads by sending requests to a vulnerable target, which then executes the worm, and you continue. Payloads can be pretty much anything for these, because you've got code execution. You've already won. So web viruses, these are the things that you're thinking about right now, like MySpace.com or the Yammer worm. And the reason I call them web viruses as opposed to web worms is that it's a lot like a traditional COM infector or EXE infector from back in the day. With the Sammy worm, I infected one profile on MySpace. Ray comes along, he looks at my profile, now he's infected. Just like the old COM and EXE infectors, they'd have one program, you execute it, it finds other executables, but it never really leaves the computer until somebody puts it on a floppy disk and trades Doom around the office. So with webworms, it just infects that island, it just infects that host. These are traditionally written in JavaScript. You could probably write it in Java using an applet, because Java applets can actually connect and talk back to the host. You could probably do it in Flash. Flash and Java have some interesting sandboxing technologies. I honestly haven't looked at them all that much, but Flash can actually have JavaScript embedded in it. It's got some neat ability to make HTTP requests. So, who knows? Maybe that's something to check out. These are completely OS independent, because they're all running, they have something in the browser that interprets them. I got a JavaScript interpreter, I've got a Flash interpreter, a Java virtual machine. These things will run, certainly for JavaScript, not so much for Flash and the Java virtual machine, but these things will run on a Linux box using Firefox. They'll run on a OpenBSD box with links, I guess, if they support JavaScript, I don't know. And the key thing here, as opposed to web app worms, which propagate from host to host, these run and run on the server. These actually run on the client's machine, and then they run from the client's machine. Simply viewing an infected page, the HTML pulls down these Flash objects or these JavaScript objects. It executes in it. Payloads can be bad. There are certain DOM restrictions. I mean, JavaScript can't access local files, nor can Flash, nor can Java unless it's signed. So even though there are these restrictions, payloads are still bad. At its very basic, with JavaScript, I can steal your cookies, which everyone goes, oh, you stole my cookie. No. What cookie stealing means is I just hijacked your session. And from Yahoo's point of view, I am now you, or from Amazon's perspective, I am now you, and I am, filling your shopping cart full of porn. So that is what cookie theft is. It's session hijacking. I can keylog you. I can scrape your form values, steal username, passwords. From the advanced point of view, I recommend you to go check out Cross-Site Scripting Proxy by Anton Reger. It was basically a way to make a bunch of botnets. Jeremiah gave an excellent presentation this morning about port scanning and just massive ownage, stealing browser history. I mean, there's all sorts of stuff you can do. I have a feeling next week is going to be very, very interesting when the advertisers get their hands on that and realize not only can they steal what OS and what your screen dimensions are, they can start finding out your browsing history. So how do these things propagate, right? I mean, they got to get from somewhere to somewhere. And what we're ultimately doing is we're exploiting some type of web application. We're going to send some specially crafted attack at some target. And it's going to execute code on the target or inject some type of code into the database. Maybe more exotic. I'm going to reflect user script and poison some caches. I mean, I don't really want to go into that, but there's some crazy stuff you can do to propagate these things. The key is, this is web stuff, right? It's all traveling over HTTP. I mean, if I'm sending single ticks or whatever, I mean, assuming that you don't have that SSL blinding your IDS, we should be able to detect that you're launching cross-site scripting attacks and stuff, right? I mean, they're known signatures. We should be able to find it. The problem is that detecting attacks in the application layer is actually quite difficult. First of all, you can't turn off port 80 on your firewall. I mean, you've got a web app, right? It kind of defeats the purpose if no one can talk to your web server. So right out the gate, I'm getting into the juicy center of your application or your enterprise. Port 80 is the most commonly open port behind DNS. So you can't stop it at the border. What you simply have to do is say, is traffic that's coming to me as an HTTP server, is this malicious or not? And the difficulty is how do you define delicious? I define that as ice cream and chocolate syrup. But I define malicious as things that are not normal. And this is what most people do. They'll take a baseline of what is normal behavior and say anything that's not normal must be bad. The difficulty in this is that normal is an incredibly moving target. As the day advances, the people who are using your app changes. I always hear that Blizzard and Battle.net gets a massive hit when it becomes like 4 o'clock in the afternoon in Korea, because everyone goes home from school, logs on, and starts playing StarCraft and Diablo, and World of Warcraft, of course. So, the types of people who are hitting your site change. And suddenly, that 4 o'clock school bell and everyone hits Blizzard, that's got to look like a distributed denial of service attack. I mean, half of Korea just logged onto your servers. So, these things change. How do you know what's good and what's not good? There's my personal favorite, massive unanticipated traffic escalations. I actually gave a cool talk at ShmooCon about how to actually cause slashdotting by using SQL injection or cross-site scripting to, like anger the masses of Linux nerds. But, if your site gets slashdotted, you just had 50,000 people visit your site in less than an hour. That's going to look like an attack to your IDS because that sure as heck is not normal. So all this stuff is changing. Obviously Buy.com has more visitors during holiday season. I mean, normal's constantly moving, and this concept of saying malicious is everything that derivates from this little, baseline we created simply doesn't work because you spend all your time refining your baseline and rarely any time not training your web app firewall. So even normal site use can look like an attack, right? I mean, first of all, ASP.NET has this wonderful thing called view state, where basically they're pushing information to the client only so the client can replay it back to them. Are there any ASP.NET guys here? I really want to know why you did that, because I mean, you wanted to it's basically saying, as a server, I don't want to deal with this, I'll just push it to the client. But, by default, you guys don't sign the view state, so I can actually tamper with it, unless you actually tell me not to. But so, needless to say, every time I post back to an ASP.NET site, I'm sending kilobytes of data, on the order of 4 to 8, depending on how large of a forum we've got. I may be uploading files to, a forum, like avatars for, the forum for my funky little image. The other fun thing is we're in the land of search engine optimization, right? We all want Google to crawl us. We're deliberately designing our sites to be friendly for something to automatically run through your entire site, find all your content, and act on your content. Well, that's exactly what I'm going to do. I'm going to run through your site, I'm going to find all your vulnerabilities, and I'm going to own you, and you actually made it easier for me to do that. Also, since we deliberately want sites to be robotic friendly, we design them this way, and we also expect one or just a few ranges of IPs to request massive amounts of traffic, because it could be a crawler, right? We don't want to disallow that. That looks normal. Large sites also expect hits from all over the globe. In 97, it probably would be a little odd for Sudan to start visiting your website. And if you're Citibank, it probably still today is a little odd for people in the Sudan to be visiting you. But, I can go through proxies all over the world, and it's not going to seem suspicious. We also now have international character sets. I start typing kanji into a form because, it looks just fine for me in Japan, but, that's Unicode. How's your app going to handle that stuff? Suddenly I'm sending you a bunch of, weird-looking, almost binary data, and anybody who's done any buffer overflows using Unicode knows it's a whole lot of fun to try to get opcodes that are actually valid Unicode. You can't tell whether it's shell script or whether it's somebody's name in Japanese. So AJAX also plays havoc with HTTP connections, because suddenly you're getting connections all the time. You're getting, pings, it's always hitting web services. I mean, your entire baseline is constantly changing. The end-to-end internet is gone. Proxies and NATed IP addresses are common. And, at our office at SPY, all of our stuff goes out through one IP. And apparently, I'm sorry, Bob, I got to do this because it's a funny story. Bob crawled Slashdot one day by mistake, and Slashdot banned our IP for a couple. It was how many days? It was 1 or 2? I guess not. He's hiding back there. But they banned it because we're all coming from a single IP. And so, but it's not common to have a single IP actually be 100 people, but we're behind a proxy and a NATed firewall. So, this is all tough. Further, even if your IDS can see us, it's very easy to elude it. Screw the fact that you can no longer tell when you're under attack or not. Now you've got to look for specific signatures. But the thing is most IDSs are either packet-based or stream-based. They're either looking at the IP packets or they're looking at the TCP stream. Robert Graham gave an awesome presentation at TourCon where he went out, got the latest version of Snort, grabbed the latest exploit of the week, he ran it, Snort caught it, he went in and changed one little piece of code which said, when I send this attack and you got to break it into 2 packets, break it here instead of here. If Snort was truly stream-based, if Snort was truly streamed-based, meaning that it reassembles the packets before it performs its analysis, this wouldn't have worked. But Snort says it's stream-based, but it's not. It looks at packets. And Robert Graham showed you can just go right around most IDSs just by changing where fragmentation occurs. This is just ridiculous. Every single one of those hex streams, that's all a period. I can represent a period 8 different ways from Sunday. How is your IDS going to be able to detect the hundreds of thousands of permutations of a SQL injection attack I can do. Assuming you even could find all the hundreds of thousands of permutations of a SQL injection attack, just think about the bandwidth and the performance your IDS needs to do. It's already got tons of signatures. To add signatures for web apps, you're talking just for SQL injection, 100,000 more signature analysis things it's got to do for every packet that's coming in. This just doesn't scale, and ultimately I end up winning. Dan Kaminsky actually gave a really cool presentation about this, this IDS HTTP fragment attack. Basically, he would take, obviously a web server, when it gets IP fragments, it has to hold them for a certain amount of time until the other part matches, it puts them together and pushes it back up. IDSs and web servers hold a fragment for they don't hold them for the same amounts of time. And so Dan came up with a way of, I could take an attack, break it, and when your IDS reassembles the packets, it looks just like a regular GET request. But when your web server reassembles the packets, it's actually a SQL injection attack. So I just SQL injected you, and your IDS reported that nothing bad happened. Dan Kaminsky is the man. So how does web malware send the attacks? Well, we started talking about this in the hypothetical, but let's kind of get down into it. Well, with a conventional web worm, we're actually executing code on the server. So I can do this any way I want. If I'm in Perl, I can use the Perl LWP library, which makes writing HTTP clients literally a single line of code. Everyone jokes that, Java, you can be like, web server, my web server is a new web server, web server.start, and you have a web server. In Perl, it's literally like user agent equal, give me a new user agent, get this URL. I mean, it's ridiculously easy to send HTTP requests in Perl. I could use sockets. I could even use netcat, curl. I could even shell out and use wget to send my attacks. So I can basically do anything I want with a web worm to propagate the web worm. For using a pure cross-site scripting-based attack that can hop hosts, or a web virus like the MySpace and the Yammer virus, you're restricted because JavaScript. You're actually executing JavaScript. And JavaScript has kind of some limited ways it can make HTTP requests. First, we've got a unidirectional approach where we can say, I can send something from the target, from the host of the target, but I don't get to see the response. And so, and doing this is basically a blind request. I never see the response. That's not entirely true. This is how Jeremiah and Spy Jeremiah at White Hat and myself and other people at Spy were able to figure out how to port scan. Because you don't get the full response back, but you do get some error codes. I can basically make arbitrary HTTP gets to any domain on the internet from JavaScript by instantiating an image object or a script object. I can make arbitrary posts to any domain on the internet by dynamically building a form using JavaScript create element and then just simply document.forms.submit and make a post. So it can make requests anywhere it wants blind. It also can do bidirectional. This is where the host and the target can talk back and forth. This is obviously what AJAX is. AJAX allows you to send HTTP, any type of HTTP. You can even send WebDAV using AJAX to the host you came from. And I talked more about this morning, so I'm going to gloss over that. You also, Spy Labs has figured out a couple of covert channels inside JavaScript and about how to arbitrarily send HTTP to any domain on the internet. There is no hard refresh, so it's like AJAX, but it doesn't have the security restrictions of AJAX. Now, it's kind of low bandwidth because we're using some interesting side channels, and hopefully we'll be publishing some more about this soon. All right, web application worms. So really there are two types. I'm going to forget about cross-site scripting for now and just focus on conventional web application worms, which these aren't hypothetical. This is real and in the wild. This is the Perl.Santi is a great example of a worm like this. Basically what happens is these things run on the underlying OS of the web server. They're written in almost any language, Perl, PHP. Like we said, the payload tends to be OS specific. The exploit, it exploits a vulnerability in the target host web application. And I almost always have to allow remote code execution. I can do this through a SQL injection because a lot of times with SQL injection, you actually can call a stored procedure to tell it to execute commands. Or there's just, you've got system or some of these other calls in, say, PHP or C or a CGI gateway that actually allows me to execute code. And there's always buffer overflows, too. So I'm simply executing code on the target web app. So first thing it's got to do is find new hosts. So a lot of times it can search. This is a fun thing. Once I'm on the host, I'm in the web root, right? I'm in your inet pub. So I can start saying, hey, give me all the .asp files, because this code's all running in the server. Let me now use regexes in your ASP or your HTML files and start looking for private IP addresses that are internal IP addresses, or search for other IP addresses, and just basically find references to other websites and go and attack those. Or I could ask a third party. You know, this is kind of where Johnny Logg's Google hacking comes in. Once I own a site through like a PHP BB vuln, the code that's running on the server can now contact Google, look for more sites that are running PHP BB, and then from that site I compromised go. As you know, I really like this analogy H.D. Moore said. It's that concept of, you know, this island has become infected with the plague, and now I'm going to send a little guy over to this island and infect them too. There are some limitations when you're doing this. If I'm attacked, well, actually, in terms of payload and propagation, I can already execute arbitrary commands on the host. I mean, I got command execution. So I can find new hosts. I can do any type of payload that I want. And I can also send these requests, like we talked about using sockets or Perl or whatever, to other hosts. Now, there are a couple limitations. If I pop your a web app and I'm obviously running, as you say, in Linux, I'm running under the HTTPD user, the Apache user. In Windows, I'm running, say, maybe as the ASP.NET Worker process. I'm not an administrator, so I can only do what the web server did. And a lot of these limitations are given by the underlying OS, the type of security restrictions they apply. At the very least, I can start or I can, you know, change and modify web server settings because I am the web server. We're going to run through that because I don't really care. All right, does anybody have any questions? Yes. I knew people would ask about this. Yes. I don't really want to discuss that right now, but we basically found some side channels in some ways that JavaScript can make requests. And we found a way to basically get other types of information on these side channels. They're not very large capacity. This won't replace AJAX, but it allows you to have bidirectional communications without hard refreshes like a GET or a POST or something like that. And we're still doing research. I'm sure, I've talked with Ray a little bit about this. I'm sure the VP of engineering right there is going, oh my God, we did what? So, you know, we'll hopefully be discussing this soon. Let me just say that. All right, anybody else have any other questions? All right, cool, moving on. Web application viruses. So this is your myspace.com, your Yammer worm, all those other fun stuff. Again, real live threats. None of this stuff is theoretical. All of this is in the wild. Essentially, what happens with a web application virus is we're reinfecting the backend database and injecting it with cross-site scripting. So, you know, Ray goes, he visits a page. I've injected cross-site scripting into, you know, he visits my profile. I've injected cross-site scripting into my profile. Ray reads it. The code downloads, you know, the HTML and the JavaScript go down to Ray's machine. AJAX or whatever mechanism I want to use runs, contacts this, you know, host, this social networking host, and reinfects it again. This is that concept of, I can never leave the island, but man, I'm going to get everybody's profile eventually, or, you know, they'll just shut the server off. So is virus really the correct term to use here? I would say yes. We're really just infecting pages and hosts on the same pages and databases on the same host. Each infection increases the chance that any arbitrary Joe Schmo user is going to come in contact with an infected page. So it's growing exponentially. It can't spread from the host program. It can't leave. It's on that site. And your payloads are generally geared more towards information stealing than destruction. And the reason for this is that we're in JavaScript. We can't access files. We can't delete files. We can't do stuff. I would make the argument that theft is more important than destruction sometimes. Sometimes I could go in and be a real jerk and delete your entire web root. But the fact that I grabbed your entire user database list or all the credit cards out of your web app is probably a little bit more important to you than the fact that I didn't deface your page in the process. So it's interesting. These limitations actually prevent most of the damage we can do to a host, like deleting its files or things like that. So what are the implications of this? This thing is huge. It's truly cross-platform. We saw this with the MySpace. Everybody who was using a Mac or you know, whatever platform, whatever browser they were using, it would run on it. This is truly cross-platform. A lot of these binary attacks, these worms and things from back in the day that said they were cross-platform, all they really were was a single piece of code, and they were able to somehow detect what platform they were now running on. Oh, this is Windows XP versus Windows 2000 versus Windows 98, and then launch the proper payload. It wasn't, the same payload didn't work on everything. Well, we're a web layer. Everything's interpreted. Everything's run in a virtual machine. It'll work on everything. This would work on cell phones that understand JavaScript. Now, the little T-Mobile sidekicks they have a web browser in them. Those actually don't interpret JavaScript. But I mean, that's the type of device I'm talking about. Your Palm, your Trio, anything that's got a web browser that understands JavaScript can further the infection. Now, this is very interesting. These are immune to conventional forms of virus detection because this is stored in a place that viruses normally aren't. The virus is stored in the database with other highly dynamic content. Meanwhile, your McAfee virus tool, it's expecting to work on files. I've got the Yammer worm actually in this box inside a SQL database because I've injected it into a web app. McAfee doesn't fire off a warning saying you've got Yammer in there. But as soon as I copy it to a text file so I can show it to you all, it pops up a warning saying, hey, I found this file and it's got Yammer. So antivirus tools work on files, not text snippets in a database. So once I start injecting your database or I start moving this stuff around, virus scanners aren't going to detect them. Your virus scanner isn't going to hook your web browser or hook your database. It hooks file systems. So the end user and the server user don't really have a way under traditional antivirus technologies right now to even detect this stuff. And like we said, the other interesting thing is if you've got integrity software like Tripwire or you're using MD5 sums, I'm not modifying your file system. I'm not modifying your code paths. I'm not modifying your binaries. So yeah, I haven't violated the integrity of your system. You don't know you've been broken into, and your antivirus stuff can't detect that you've been broken into. So it's also immune to any type of bad JavaScript filter, right? Because, I mean, that's what we're talking about. It always depresses me that our clients and stuff will come to us and say, you know, what can I do to not be a victim of cross-site scripting attack? And unfortunately, the answer right now is not a whole lot, because the attack is that I inject JavaScript into the machine, and your browser doesn't know it shouldn't run this block of code. I mean, why wouldn't it run this block of code? It came from Google. I should execute this JavaScript. The only way you could really prevent this on the client side is create some type of magical box or filter that can say, given some arbitrary piece of JavaScript code, I'll tell you whether it's bad or not. It would have to be on the client side, and you know, so this is exactly the same problem as detecting malicious HTTP traffic, because malicious JavaScript just looks exactly like regular JavaScript. First of all, it's going to request images. It's going to request script. It's going to make maybe multiple external domains. You know, I contact some ad server. You know, if I inject a little piece of script that goes and contacts evil.com, how is that any different than these you know, news sites that have a little piece of JavaScript that goes talks to adserver.com to pull down some JavaScript, you know, underline some of the words and you hot link over them or whatever. I mean, it looks like normal JavaScript. It does exactly what normal JavaScript does. It's going to hook on events, on mouse over, on submit, on click. It's going to modify and manipulate the DOM tree to access elements, create elements on the fly. I mean, this is exactly what regular JavaScript does. It's exactly what malicious JavaScript does. You're screwed. You can't figure it out. I could write a PhD thesis about how to do this, but I'm not a doctorate student, so that's probably not going to happen. Someone wants to do that, they can, but this is a very, very hard problem. And this is also why Layer 7 is very interesting, because it's full of hard problems like this. You've got to analyze what's coming back and try to figure out, is this good or is this bad? And everything we know about how to determine whether something is this good or is this bad involves signatures, involves all of these other things, and it simply doesn't work at Layer 7. So if you're a computer science student right now, you really should consider going into web application security. And if you are, you should seriously come talk to me, because I left college, went right into it. Well, no, I graduated from college, but I went right into it, and I am much happier working at Layer 7 than any of the other layers, because there are still a lot of very interesting computer science problems to solve here. So again, I don't want to harp on this, but you really think I'm selling fear by saying cross-site scripting will destroy the internet? Well, consider a traditional information stealing Trojan. I install a keylogger versus I exploit a web app, or you know, let's say Gmail, and I install a keylogger there. All right, well, let's think about this. So what are the pros and cons? Actually, I already have an example here. I infect a shared catalog on a web-based CRM, say like Sugar CRM or something fun like that. Any user who views an infected page gets their calendar infected, spreading the virus all along. So one page view causes the spreading. The payload is that I have a keylog that then hooks, and because I can infect multiple pages on the CRM, I can persist the keylogger across the entire application. So I can now view all of the keys for all of your internal application. It's not you leave the page and it's gone. I can persist it now because I can inject everywhere. Excuse me. So think about this. What's going to happen? I'm keylogging everything that you ever enter into this application. Well, if I have a traditional keylogger installed, I'm going to find that using traditional techniques. I've got a virus scanner. I'm modifying some binaries. I've got something nasty running. There's web malware detect, or there's you know, what is it, Adaware. There are all these things to try to find malware that's doing nasty stuff. But think about a web-based attack, right? All your integrity checks pass because I haven't even modified the binary. All the hooks, the operating system hooks for keyboard events and mouse events, I haven't modified your OS. I haven't injected your interop tables. So that all works. There are no cloaked processes. I'm not hiding anything nasty. The user's browser hasn't even been modified. The only thing I've done is spawned a little thing in RAM, and that's it. This works across all platforms, all PDAs, and there's no trace the virus even existed, except for occasionally when I send the keystrokes to some third-party site. I mean, you don't know it's there. As soon as you close the browser, it's gone. So let's start talking about real-world stuff here, because I've got, what, a half hour? All right. So Perl.Santi. This was a conventional web application worm, pretty much hit in December 2004, most of the spring of 2005. It used Perl with LWP. Sometimes it used sockets. There were a couple variations of it to actually make requests to other web apps. Now remember, web application worms are the code that uses remote command execution to get into the web server, and then from the web server finds new hosts and goes and infects them. So the attack vector was I exploited this highlighting bug in PHPBB that would let me get code execution on the host. And then what I would do, as soon as the code ran, it would do a Google search, and it would say use a static string. It was something like search for powered by PHPBB like 2.4 or something like that. Used a static string to search Google for new hosts. And then it would send requests to those hosts trying to infect them. The payload that ran, once it actually found new hosts and spread, was it just defaced all your HTML pages, things like that. Now, there were some interesting downfalls to the Perl worm, or the Perl.Santi worm. The thing was is they asked Google to go find other hosts I can infect. And so Google basically could clamp the spread of the virus. If Google doesn't return any results if you search for this particular string, the virus is never going to get any new host to go and infect, and it's going to stop. And there was a static string inside the Perl, or in the Perl source code that said, send this string to Google. And so all Google said is, I'm not going to do that. It used an extremely poor host selection algorithm. It basically said, let me randomly generate a top-level domain, a country code like .co.uk, .co.ca, US, things like that, and also randomly pick some version of PHPBB that I know is vulnerable, fetch the page, and then go to like some random number between 1 and 10, and that's the host I'm going to infect. This was a really poor algorithm, and Perl.Santi kept trying to reinfect the same, couple hundred results Google would return. So it didn't spread all that far. And so what Google did, still to this very day, if you do a Google search for the static string that's in Perl.Santi, it comes back and says, a computer virus is sending us automated requests, and it appears you've been infected. We won't honor this request. So that's how they clamped it. There was no mutation of the source code. It was the same source code. You could write a signature for it. I'm going to talk about how you actually evade signatures. The search string, the attack string, they were all static. And the payload literally just defaced your site and gave props to nevermore, no Santi webworm. Oh, and it had this little generation. This one's generation 11, meaning this thing hopped through 11 islands before we got to this one. So it spread pretty far. But it was limited pretty much the first couple hundred or so hosts that were on Google. So the MySpace.com virus. This thing's pretty cool. This is the web virus. Basically October of 2005. I know the MySpace guy's getting really sick of us talking about this, but it's a very good proof of concept. It was a very interesting worm. It infected the 5th largest domain on the internet, which surprised me because I didn't realize it was that large. It used JavaScript and Ajax. The attack vector was I injected some script into the user's profile. When you viewed my profile, Ajax then injected the virus into whoever was viewing it, their profile. We then added Sammy as their friend list and appended Sammy as my hero to their profile. And I seriously want a shirt that says Sammy is my hero, because this was an interesting piece of work. I mean, no offense to the MySpace people, but you know, because I know it did cost you guys lost some revenue because you had to shut the system down. And this was very interesting, and actually, this was very much a bell ringer, because less than 8 months later, we're going to talk next about the Yamana worm, and we've gone to criminal enterprise. And this was really good. This really brought the security people to start going, whoa, you did what with JavaScript? Holy crap, you took down the fifth largest site on the internet with something that I just supposed to steal cookies and pop alert boxes? It really woke people up and realized that cross-site scripting is much more dangerous than we thought it was. So input filtering is very, very hard, and MySpace learned this the hard way. They do a really good job, and my props to MySpace, on filtering. They wouldn't let you use script. They wouldn't let you use the sequence of letters JavaScript, inner HTML, certain characters like double quote, things like that. But unfortunately, just blocking script wasn't good enough. What the attack actually did is created a div and said the style was this background, and that allows you to specify a URL. And then they used a JavaScript URI, which says JavaScript : execute this code. And so as soon as this div tag would load, it would go, oh, there's a background here. Let me go grab that. Oh, it's JavaScript. Execute. And so it was instantaneous execution of the code. Also, whitespace was their friend. They did tag, inner dot, and then they broke inner HTML up. So that, and they also used /n inside JavaScript and different things like string, char from code to dynamically build strings representing sequences of letters that MySpace normally filters. So they build them on the fly to get around the filters. There's also the eval statement, which also is in Perl too. Basically, you give the eval statement a string, and the string contains JavaScript. So what the MySpace guys did is they had a div tag, and they had, this was kind of neat, they had expression equals alert, and they actually set basically an attribute that didn't normally exist on a div tag called expression, and that was their actual payload. And then what they did is, because inside you'll notice my expression there is just alert with a double quote, and then inside the alert are single quotes around XSS. Well, because the way he was executing JavaScript, it was style equals double quote, background, single tick, he already had a double quote and a single tick. So all this JavaScript that's inside, it wouldn't be able to have any quotes. So what he did is instead move the payload out of the background style, and he just said, you know, background is JavaScript : eval, and then he said document.code, go grab the div element, specifically the expression attribute, and then execute that, which was really quite neat. It got around filters. It shows that it is very hard to filter web apps effectively. And you can go to this website and read a lot more about the technical challenges. It was a very, you know, again, I don't want to smack MySpace around because they did a good job filtering. This was just a very, very neat and interesting hack, and everyone should acknowledge that. So I talked about this morning. The infection mechanism was really cool. Remember, we talked that Ajax is only allowed to talk back to the site it came from. So what happened is that you view profiles on MySpace on profiles.myspace.com. Well, the code to modify a profile doesn't actually exist on profiles.myspace.com. It exists on www.myspace.com. So what this virus did is you make a request to view, you know, Billy's profile on MySpace. The HTML comes down and it's got embedded JavaScript. And the only way I could really represent that was with that menacing skull and crossbones. So the very first thing the browser does is it goes, I need to somehow modify their profile. I can't do it at profile.myspace.com. However, www.myspace.com, not only can I edit profiles, I can also view profiles. So the very first thing the virus did is said, no, go request this page we're at right now for Billy's profile, but request it from www.myspace.com and everything else. And so that's what the first red line is. It goes and your browser makes a request for www.myspace.com and the profile. The same HTML comes down with the embedded JavaScript. The first thing it does is it makes a request saying, I want to update my profile. And what happens is MySpace basically pushes down this one-time little hash. It's almost like are you sure you want to do this? And it included in there, I believe in a hidden HTML input, this little hash. And you had to click, yes, I'm really sure I want to do this. And it would send that hash and the new profile back to MySpace and actually change your profile. So the worm would then say, hey, update my profile. The response would come down. They used a regex to extract this hash and then make another AJAX request saying, here's the magical ticket you just gave me. Here's the payload. Yes, seriously, let's own this guy. The next thing it did is it had to add Sammy to your list of friends. So I don't include that on this graph, but it also then made another request to invite Sammy, and then I believe when it infected your profile, it also added Sammy as my hero. This should scare the crap out of you, because you visited one page and JavaScript fired off 5 requests. Other than the very first request to switch domains to www.myspace.com, you didn't see any of them. AJAX is a double-edged sword. The same cool technology that means I can use Google Maps and have it be completely invisible and nice and smooth, and I don't see all this stuff going on in the background, means that when that stuff going on in the background is you getting owned, you don't know. And that's exactly what happened here. From your point of view, you're still looking at this profile. But in the background, you just made 4 requests, 5 requests. Now, the other cool thing I talked to, do I actually say it? No, I don't. The other interesting thing about AJAX that I talked about this morning, the server can't tell the difference between a HTTP request made by JavaScript using AJAX and an HTTP request made from the user clicking on a link or submitting a form. So the user's point of view is I viewed a profile, it came down, and then I did a refresh, but I'm still looking at the same profile, everything is okay, and in the background it's doing all this badness. From MySpace's point of view, you visited a profile, you then visited www.myspace.com, you then said you wanted to update your profile, and then you confirmed it, and then you added a friend. From MySpace's point of view, nothing bad happened. That's a perfectly logical sequence of events. It's perfectly valid. It might have looked a little suspicious that was happening about half a second after each other's, but that's not their fault because I could have thrown in a JavaScript timer that said wait 4 seconds and then update their profile. So, I mean, it's really kind of tough. You're in a spot because from a server point of view, they don't know that something bad's happening. And from a browser point of view, you don't know something bad's happening. But believe me, and those red arrows I made, there's some bad stuff happening. So what you gonna do? Well, so I did not write the Sammy worm. I actually did have friends call me and say, did you do it? And I hadn't even heard about the worm. And I was like, what? Because I was actually out at TourCon 7 talking about using cross-site scripting in AJAX to do really nasty stuff. And then a month later, this thing happened. And everyone assumed I wrote it, and I did not. Sammy did. But it's an excellent proof of concept how AJAX, even though AJAX is restricted, it's only allowed to talk back to the host it came from, I can still screw that host. I can still infect things. I can do all sorts of stuff. I can't leave the island, but I can infect everybody on that island. It showed the web server can't tell the difference between the requests. It also showed how JavaScript plus AJAX plus regexes means I can get through pretty much any complex login sequence you throw at me. Short of CAPTCHAs or two-factor authentication with the secure ID token, AJAX and JavaScript and regexes can get through it. And assuming I know the passwords or I can brute force them. MySpace really lucked out because it wasn't anything nasty. It was, you know, some punk-ass kid having fun. And seeing as how I used to be a punk-ass kid who had a lot of fun, I can kind of relate. But it got bad pretty quick. And the badness that got pretty quick was the Yammer worm. This was, it's kind of nasty to say whether this is a web virus or a worm because it had the potential to send emails to people outside of Yahoo, but it didn't. And that's simply because Yahoo had that functionality. It's a mail, I mean, their webmail is a mail client. But basically in June of 2006, it infected and took down the 3rd largest web email provider, which is Yahoo. Again, this should sound, you know, a nice little repetition to you. JavaScript plus AJAX equals bad. It propagated. It had a JavaScript inside a message. You looked at the message. You know what? Let's just look at the source code, because that's a lot easier. I did this morning, so if you saw that, I apologize. So here was the actual message that was sent to the users. And I'm certainly not the first person to show you. This has been floating around the internet, very easy to find for months. So Kevin, I'm not making a disclosure I shouldn't be making. We got an image source, which is just saying, hey, here, it's just an HTML message. Hey, here's an image I wanted to include in my email. When this image is done loading, when this image that I specify in source is done loading, right here, on load, run this big block of JavaScript, which is about 3K of JavaScript. And right down here is where it starts. They wrote a little function called make request to kind of make stuff easier for them. It's right here, but basically, given a URL, it instantiates a object, an XML HTTP request object, which is how AJAX happens, and takes care of all the sending. So the first thing it did, it says, hey, once the virus loaded, it said, hey, contact Yahoo and ask for the address book. And when you're done, go talk to list contacts. So we go up here, and the list contacts function spawns. It says, hey, if I did get the request back and the request was a 200, go ahead and extract, right here, this function, get IDs, extracts out all of their email addresses, and it stores it in ID list. It next says, make a request, and when you're done, to, notice this, make a request to mail.yahoo compose and get crumb to call this function when you're done. Yahoo kind of had something similar to MySpace where they said, are you sure you want to send this message? They basically pushed down this little magical ticket they called a crumb as a variable name, and when you send the mail message, you actually had to give them that crumb, and then they would, they'd actually send the message. So once I grabbed your address book, go grab the crumb. When you've gotten the crumb and you got back a 200 OK, go ahead, extract it, and now it said the contents was, this is a test, the subject of the email was new graphics site, here's the URL we're going to send to, we're going to do a lot of nastiness, and then right here, the blind carbon copy list is all of the email addresses. So it made one giant email to everybody in your address book, and then once it was done sending this email to everybody in your address book, thus spreading the virus, it said alert contents is the file it wanted you to call. And then right down here, alert contents basically says, once you're done spreading the virus by emailing everybody who had a Yahoo address, go ahead and window.navigate, go send right here ID list, which is the address book, send the address book to www.v3.net. So not only did they propagate a worm, they then stole your address book to start sending you spam, which is a darn shame. This is actually a second variant. There was one, it was right up here at the top. They actually tried to do a window.open and pop up some advertising, but they actually fat-fingered it when they typed it. And they had www, comma, some ad server.com. And so they weren't actually able to pop up advertising, which was kind of funny to find a typo in somebody's code. So I kind of wanted to email them and be like, yeah, you fat-fingered this. I took the liberty of patching it for you. Here we go. Okay, so here's the scary stuff. MySpace.com, Sammy screwing around. Yammer virus, stealing addresses, written specifically to harvest email addresses for spammers. 8 months to go from proof of concept to criminal enterprise. These guys are already using it. It's not punk kids or 13-year-olds in Brazil just screwing with you, which is what, I'm not picking on Brazil, it's just the Perl guys. The Perl.Santi was written by a Brazilian, 13-year-old Brazilian dude. These aren't just kids screwing with you. These are criminals who realize that they can use cross-site scripting plus AJAX and take down very, very large sites. I probably should delete this. Yahoo shouldn't be all that ashamed. I mean, it is difficult to filter image, but the onload event is a pretty common, well-known way to execute script. They probably should have done a better job filtering it, but what you're going to do. So, all right, we kind of talked about state of the art. I got 15 minutes left. Why don't we talk about how to destroy the internet? Let's talk about how bad this stuff actually could get if it wasn't a 13-year-old Brazilian just screwing with you. All right, the Perl.Santi were real examples. They both had very childish payloads. Sammy is my hero, and I defaced your site. I actually wrote this part of the presentation. Like I said, I presented it in January. This was before the Yammer worm hit. So I'm gonna propose 2 hypothetical and truly evil samples of extreme web malware. The first one is the Schwagmo web worm, and the second one is the 1929 web virus. So Schwagmo is Holy Mother of God, we're screwed backwards. Because if I did it right, it would be bad. This would be a web worm that propagates from host to host, moving from island to island, infecting you with multiple SQL injection vulnerabilities in different web apps. So I got a SQL injection vulnerability in PHPBB. I've got a SQL injection vulnerability in vBulletin. I'm using these to do remote command execution. It would propagate by using Google to locate new sites for one of the SQL injection vulns we know about. So let's say I got 5 vulnerabilities I know about. The first generation looks for vulnerabilities in the first site. The next generation, next site. And it just rotates. So I'm not just hitting one type, I'm hitting multiple types. So now you got to wait for multiple vendors to fix the problem. The other thing we want to do is we want to mutate our search string so that we avoid the bottleneck this Perl.Santi worm had. So, Google just stopped returning results for that search string. I'm going to keep changing my search string. So I'm going to look, all in URL, the modifier for Google, is very similar to the in URL modifier. I'm going to start adding words to my search string that I know Google's going to throw out anyway, like in, the, of. So the search string I'm sending keeps changing, but Google, it's returning the same results. There's actually an algorithm to generate English words that are proper English. They don't mean anything. Or I could just access user local. So I could say, find me all the PHP, powered by PHPBB version 2.4 and kitty cat. Find me PHPBB v5 and doggy, and change their ordering, flip everything around. I can mutate this search string like no tomorrow, and you won't be able to fingerprint it. If we don't get a results page, Google detected our search string, so randomly select a new search engine. I mean, MSN used to be not a very good search engine, and it's pretty good now. It supports things like in URL, in title, some of these fun things you can do for Google hacking, the other search engines support. So, Google is not the only search engine. We all use it. We all probably think it is, but in the cases when you're writing a worm, use other search engines so they can't clamp you. So now I got multiple vulnerabilities that got to be patched, and I got multiple search engines who have to stop all these permutations of attack strings that I'm using. Now this is the fun part. We're going to mutate the virus source code. We're going to have a polymorphic worm. And because we don't want you to write a signature on it. First of all, it's an interpreted script, so it's a lot easier for me to mutate it. I could just throw a new comment at the beginning. That'll mess up the MD5 passum. I could actually change the structure of the virus. Instead of having like a for loop, I could have a do-while loop. Instead of having an if-then-else tree, I could use a switch case statement. So I could actually change the structure, the source code of the virus, but it'll still execute and do the exact same thing. I could encrypt it, which has been around with polymorphic webware or polymorphic viruses since like the late 80s. Also, Perl is the text parsing king. Perl routinely, you can put Perl at itself and it'll process it. In fact, we've got an intern at SPY, a guy named Nathan, and he was telling me, he was talking with some guys online, and apparently something like 17% of everything you get out of a random number generator, just if you convert it to ASCII text, is valid Perl syntax. It'll execute. I love that. That just is a testament to using Perl, right? So I can do anything I want and obfuscate the hell out of Perl, and you're never going to find it. And I can do complex text replacement. I got like 10 minutes, don't I? Ooh, all right. I'm going to go faster. Okay, so if I have known vulnerabilities, I have known applications, right? Because I'm doing SQL injection. If I have known applications, I have known database structures. If I'm injecting vBulletin, I know there's going to be a table for pictures, a table for accounts. So let's start dumping username and passwords to *. I SQL inject you, get all your username and passwords, and then dump that private information to public forums. Because again, the Holy Mother of God, we're screwed. I want to do as much damage as I can as quickly as I can. Now, I'm not advocating this. I'm just saying this is worst case. Now, or maybe I don't want to. Maybe I want to drop 100,000 tables all around the internet. Just delete. Gonna kind of suck if you're in e-commerce and I just dropped all your orders table. I just totally screwed your logistics package. Where are your packages going? I don't know. Nobody knows. Maybe I'm just gonna insert junk into your database. Maybe I just start screwing with FedEx, right? Don't worry, we use FedEx or whatever the thing is. Well, I'm just going to start making up, FedEx packages. If it's an e-commerce site, I'm just going to start ejecting fictitious orders. A lot of times, simply stealing the information is bad, but sometimes simply corrupting the data can be a heck of a lot worse. Or I've actually seen ploys where people will break into a site, encrypt the person's data, and then ransom it and say, we'll give you the encryption key to get your data back. And normally, they just replace the data with random data. Nothing is actually encrypted. Here's the other fun thing. I'm also going to, Schwagmo is going to start using the SMTP libraries of Perl. I'm going to start mail bombing the mailing lists that the antivirus vendors use, and CERT uses, and everything. So the people who have to talk and coordinate how to respond to this are dealing with massive email floods. So multiple SQL injections, multiple vendors, and none of them can talk to each other because I'm flooding their communication channels. How bad would this be? Improvements. Like, we should really improve this thing, right? Will vary exactly how much of an impact this has, but suffice it to say, it's going to generally be very, very bad day to be working in InfoSec if this ever happens. It could be defeated by backups, sure. You could stop the clock, roll everything back, and be okay. Google might be able to implement a filter, but we have multiple search engines. There could have to be a balance between the number of hosts that I infect. I mean, I could start the virus with lots of vulnerabilities. I mean, there's a lot you could do here, but suffice it to say, this is all very bad. So, 1929 web virus. Let's talk about something with cross-site scripting and AJAX that could destroy the stock market, because that's always fun too, and this is very deadly and dangerous. And luckily, E-Trade actually did something about this, and we'll talk about that. So, hypothetically, again, none of this is real. I didn't write this. Please don't cart me away. We're going to infect a major stock trading site with cross-site scripting. Maybe it's in some type of customized stock ticker or user portfolio, something like this. The cross-site scripting exploit, I get the script in there. Anybody who views this script, I use AJAX to blindly infect maybe their custom stock ticker or post a message to a forum, something. I propagate it. Now, hopefully, if you are a stock trading site, the place where your forum is a different subdomain than your stock trading site, so AJAX couldn't talk. But we saw with MySpace, they had profiles and www, but because they both pointed at the same place, I'm able to get around that. The payload is, I'm going to use AJAX to make the worst buy and sell stock trading decisions you have ever seen. Now, remember, complex confirmation pages, not a problem. Are you really sure you want to sell all your stocks of, Ford? Yes, I do. Short of a CAPTCHA, actually E-Trade. E-Trade actually implemented two-factor authentication. Our VP of product management is here, Eric Peterson, and he actually, when I was giving this talk back in January, he held up this little secure ID token he got from E-Trade. And he said, yes, E-Trade, whenever you do a stock trade, you enter in the little number that's on there. And I had read about this, and apparently E-Trade, they'll give those to you for free if you have more than $50,000 invested with them. Or you can pay, $100 and just get one. And so I'm like, so Eric, you have $50,000 invested with E-Trade, or did you pay the money? He's like, I don't think I'm going to tell you that, Billy. But this is very good, and I applaud E-Trade. This is a good step. Two-factor authentication, when you're dealing with money, is a very, very good idea. So they should be applauded for this, because I'm not saying any of these people are infected, but if E-Trade did have a cross-site scripting vulnerability, I'm not joking, I'm not even trying to insinuate that any of these people do, but if they did, the two-factor authentication would prevent something like this from happening. So, two modes. The virus is going to have two modes. It's going to have online mode, where it actually contacts a third party, and the third party can just massively tell all these bots that report into it, sell Ford now, or buy Ford now, or do whatever. Also has research mode. Let's say the virus, for whatever reason, can't contact a master to tell it what to do. This was a fun computer science project. How can something decide what really good and bad stock trading decisions to make? So it goes into research mode. Online mode, like we said, we use fingerprinting, whatever. I could simultaneously damage thousands of portfolios by giving them a really bad choice. Or I put them in research mode where they figure out it themselves. So what I could do is I could use a random string and just randomly build a stock trading symbol. And then I start using AJAX to sample the price of that stock at known intervals. And then what I do is I take a derivative, which gives me the rate of change. How quickly is the price fluctuating? How quickly is it increasing? Is it at the top of a curve, or is it at the bottom of a curve? So I can figure out when a price is about to kind of stabilize or when it's going up. I mean, I'm not figuring out how to win the stock market. These are just very simple math equations. And so I'm going to figure out right when your price starts going down and accelerating, meaning it's really expensive, I'm going to tell you to buy more shares of it because it's dropping in price. So let's buy it when it's really, really expensive. And when you're at the bottom of that curve and it's about to start having a rebound, because Ford, in fact, said we do have a strategy not to, bottom out, I'm going to start selling your shares when they're rock bottom prices, when they're basically chunk bonds. So what's the impact of this? Try explaining to the SEC that you did not make that stock trade because it came from your IP. You were online, you logged in, and your trades you were doing, your legitimate trades, are mixed in with the trades the virus is making. Eventually, let's assume the stock trading site, they find the virus and they remove it. And they attempt to sort out the real trades from the virus trades. It really doesn't matter in the end. I mean, as long as I get even a couple of days of the virus making trades, external brokerage houses, external people, the virus is going to be affecting the market. How much so? I don't really know. But external people are going to make buy and sell decisions based on the buy and sell decisions that a giant block of fictitious E-Trade users are now making. And while you can roll back the clock for everybody on E-Trade said, yeah, you guys got owned, you didn't really do this, you can't give your money back to the people managing hedge funds or all the other people who were day trading that day. So this is where it gets really scary, because JavaScript, that thing that hijacks sessions and pop-ups, that just made and infected the stock market. That's pretty scary. So how do you fix all this stuff? I mean, yeah, doom and gloom. This is kind of, I mean, it's kind of fun to think evil. How would I destroy stuff? But seriously, we got to grow up. We can't all be, 13-year-old people doing DDoS attacks. How do we actually fix this stuff? Well, ultimately, web malware is occurring because I'm exploiting web vulnerabilities, right? I'm either doing cross-site scripting to facilitate a web worm, or excuse me, a web virus, or I'm doing remote code execution to do a web virus, or yes, wait, web virus for cross-site scripting, web worm for execution. So if you're fixing the vulnerability, it really stops both aspects of web malware. It stops further injection and further propagation. It also stops payload execution. So once you fix these things, everything stops, and you win. Really, your web application are like bricks in the wall. They build your website, it's the bricks. Do you really trust a brick you downloaded from SourceForge? I contribute to a lot of SourceForge projects. I enjoy it. I love SourceForge. It's great. But seriously, if you're a company and you've got applications that are important, do you really want to go grab some forum software off SourceForge and stick it on there? Your web app is only as secure as its weakest link. And a lot of times the weakest link is some piece of software you downloaded and you didn't really understand and probably hasn't been maintained in a couple of years that's rife with cross-site scripting vulnerabilities. So again, 90% of web application security is all about validating the input. Never, never, never trust anything you get from the client. I can spoof, lie, steal, do everything I can. You simply can't trust me. Hidden input forms, cookies, URL, post data, even HTTP headers. I can lie about everything. So you should never use anything you get from the client without sanitizing it. Is this a zip code? Enforce those data types. Is it only supposed to be numbers? Is it only supposed to be letters? Format-wise, is this supposed to be a credit card? If so, look for dashes and actually compute the checksum. It's not very hard to do. The last digit of a credit card number is called the LON algorithm, or also the mod 10 algorithm. It's really easy to compute. Verify that that's actually a credit card number. Length restrictions. I got, how many, 3 minutes? Got to tell you a fun story. You guys should go to Google and search for Tiny Disk. Y'all ever heard of TinyURL? Surely you've heard of TinyURL. TinyURL allows you to submit a URL, and they give you a little hash. And then when you go to tinyurl.com/hash, they redirect you back to that URL. Wait a minute, I wrote something, then I read something back. Sounds like a file system, doesn't it? So I went and I wrote a file system that runs on top of tinyURL. And sure enough, it does work. It takes a file, compresses it, encrypts it, dices it into little pieces, submits them as URLs to tinyURL, gets back basically a list of hashes, and then it just, when it wants to reconstruct the file, it just grabs all those hashes and reconstructs the file. So because they didn't have length restriction on their application, I wrote a file system on top of somebody else's web application. This is ridiculous. But they didn't validate their input. I could give them anything. In fact, when I was messing around with this, I inadvertently uploaded all of Lewis Carroll's works to a single tinyURL hash. And when you visit tinyURL/hash, it gives you a 302, an HTTP 302, and location, and the URL. Do you have any idea what IE or Firefox does when they get 270K of data in the location header? Yeah, no, I won't, but it's there, and it's odd. So length restrictions are important. You should escape characters to avoid SQL injection. You shouldn't only escape characters, which PHP and ASP and everybody else can do it. You should use whitelisting. You should say, look, this is supposed to be a zip code. If I get anything other than a digit followed by 4 more digits, throw it out. You shouldn't say, oh, there's a tick here, or oh, there's a greater than sign. That might be SQL injection, throw it out. Because as soon as I find a new way to do SQL injection, your filter is worthless. So instead of trying to tell me what you won't accept, tell me what you will accept and throw everything else away. This is called whitelisting. Input validation should always be on client and server side. Client-side validation should solely be for performance reasons, so you don't have to cross that internet cloud. Server side should only be, it's the only sure way to enforce security. Your front-end code should properly represent your back-end code. So many times I see HTML forms that you post to a page, but actually if you send those parameters in the query string, it works just as well. Over-engineering a web app is bad. I mean, if you've got, you might want to consider having an LDAP directory instead of a fully functional relational database as your back end. If you are just serving static content and only you on the client side actually insert that data and your web app is doing lots of reads, don't use a SQL database. Use an LDAP directory. Use something that's optimized for lots of reads and hardly any writes, because it's a lot easier to lock down. If you have static content, your privacy policy is probably static content. Don't serve it under a PHP or an ASP page. It should be privacy.html. In fact, I'm pretty sure there's compliance things that say it actually has to be called privacy.html. Okay, man, that's a lot of talking. Does anyone have any questions? Y'all got really quiet. This is a tricky question because technically we compete with web app firewalls, but subjectively, let me just say this. It goes back, well, no. It can be used afterwards, though. You certainly have to do security early in the life cycle. That's a given. Web app firewalls suffer from the same problem that I was describing earlier. How do you detect layer 7 attacks? Because that's all a web app firewall is. And there are just so many ways I can mutate and hide things. You basically are left creating a baseline of what normal behavior is and flagging on anything that isn't normal. And normal is such a moving target, their effectiveness is questionable. So, I mean, do your own tests. If they work for you, if normal doesn't really fluctuate that much, maybe it works for you. And that really sucks to be stuck having to manage a bunch of legacy systems and not be given the resources to fix them. I'm sorry, but okay, so real quick, as people file out, web application malware is no longer theoretical. In fact, it's no longer proof of concept. We've got criminals actually writing it. So far, they've been silly. Expect this to change. And in fact, I wrote this in January, and sure enough, it's changed. You've got stuff that's stealing email, and it's harvesting, and it's being used for criminal purposes. And stealing email doesn't sound that bad, but 6 months ago, 8 months ago, it was Sammy defacing a site. Today, it's stealing email worms. How likely is what I'm talking about destroying the stock market or massively disrupting the internet? How far in the future is that? I don't know. I hope it's very far in the future. I hope we solve these problems. But I can tell you one thing for sure, web malware payloads are going to get worse. They are equal in terms of traditional malware in the amount of damage I can do in leakage. A Trojan horse can do as much damage as I inject keyloggers into your browser. For these reasons, first of all, web malware operates on a different level from traditional malware. We're in the virus, or we're in the application, we're in RAM, we're in JavaScript, we're in a database. For this reason, traditional defenses don't work, because it's never written to a file. It's not, it's ID, or antivirus software says it protects you against JavaScript stuff. It protects you, when I download a code, that HTML file isn't passed to the antivirus software before my browser renders it. It's just rendered and I get screwed. It only gets scanned and it gets saved as a file. Because these defenses are not readily available, web application malware is actually more dangerous than traditional malware because you get the same amount of bang for your buck and nothing can stop it. No traditional offenses, at least, can stop it. Popularity and buzzwords are driving inexperienced programmers into the web application development, making these problems worse. I mean, we already have lots of problems. Go read full disclosure. Go read the pen test mailing list. Everything, 70, 80, 90% of the vulns coming out of, SANS are all SQL injection or cross-site scripting. It's moving to the web application space. Finally, properly securing your web applications, really it just comes down to input validation, and it will stop most, if not all, web malware. Does anybody have any questions? Oh, thank you.